Hello, dear chickens. Because I want to make sure that I don't get rusty on my craft, I thought I'd teach you a lesson today. And today we're going to be learning some math skills. So pay attention, okay? You ready? Because this is Mr. G's distance learning. Okay? Good morning to you all. Today I'm going to be going over the Pythagorean identities. And this one here, sine squared theta plus cosine squared theta is equal to 1 is the main identity that you're going to be working with. However, I do want to remind you that there are two other Pythagorean identities, and rather than to have you memorize all three of them, which are right here, the main one again I have bubbled for you, and here are the other two. Rather than for you to have you memorize them, I'm going to derive them for you. So should you ever forget what they are, you can always come back to the original one here, and you can derive the other two. And it's very easy to do. All you have to do basically is just divide everything by sine squared theta, and sine squared theta, and just simplify. For example, what is sine squared theta divided by sine squared theta? It's 1 plus, what is cosine squared theta divided by sine squared theta? Well, you're going to remember that that's a quotient identity. Therefore, it is the tangent squared, the cotangent squared of theta. And what is 1 over sine squared theta? Well, you remember the reciprocal up there, that 1 over sine squared of theta is, well, where would it be? Right here, it is cosecant squared of theta. So cosecant squared of theta. And hence, you have your second one here, your second one below, 1 plus cotangent squared of theta is equal to cosecant squared of theta. And you didn't have to memorize that one. The same could be said of this. Supposing instead of dividing by sine squared of theta, you wanted to divide by cosine squared of theta. Well, you divide by cosine squared of theta, and cosine squared of theta on all three sides, all three pieces, and then you simplify yet again. And what do you get? Well, sine squared of theta divided by cosine squared of theta over here would be tangent squared of theta. So this would be tangent squared of theta plus, what is cosine squared of theta divided by cosine squared of theta? It's 1 is equal to, what is 1 over cosine squared of theta? Well, 1 over cosine squared of theta is a reciprocal here, so it'll be secant squared of theta. Secant squared of theta. And therefore, you have derived the first one here. So now we're going to be applying them as we go up to our classroom, and we're going to do several examples for you so you can practice and get good at this, okay? See you real soon. Bye. Hey, wait, what happened to my students? Oh, they ran away. They were too chicken to learn math. Next time I'll make sure to get some termites because I know they like math because they like logs. Good day, everybody. Hope you're doing well. Today's lesson is going to be on trigonometric identities. And obviously you have a book at home that looks like this. We've used it for semester 1. And so if you want to follow examples, you'll see them on page 730, section 10.1, trigonometric identities. You'll also see some very interesting hints verifying identities on page 732 that you can follow along. I have uploaded into our web page through Google Classroom your sheet of the trigonometric identities that we're going to be using for the next month here. And this is what they look like. Please take the time to go into my Google Classroom and download it and see if there's a way that you can either print it or have it available by taking a picture on your phone. You're going to notice that they are numbered all the way from 1 all the way through 11. And so the ones that we're going to be using for the first few assignments on the identities are 1, 2, and 3. And so I have highlighted them for you, and that's what you should do. As we go along, I will introduce you to the other ones. But because these are somewhat small print, I am going to review them one more time by showing you these identities this particular way. And let me begin with the ones that you already know. For example, you already know the reciprocal identities. You know that sine is 1 over cosecant, or that cosecant is 1 over sine. You already know that cosine is 1 over secant, or that secant is 1 over cosine. You also know that tangent is 1 over cotangent, and that cotangent is 1 over tangent. They are called reciprocal identities because if you just take the reciprocals, you'll see that they reflect each other, okay? The other ones that we're going to be using are called the quotient identities. And of course, you know that quotient means division. That means that we're going to be dividing. And so the identity is that the tangent of theta is equal to the sine of theta over the cosine of theta. And if you take the reciprocal, because the tangent is the reciprocal of cotangent, you just flip it over and you'll see that the cotangent is equal to the cosine of theta all over the sine of theta, and these are quotients. That's why it's called the quotient identities. The last ones that we will be working with the first set of identities are called the Pythagorean theorem identities, or the Pythagorean identities. Now, I have bubbled sine squared theta plus cosine squared of theta is equal to 1 because this is the single most important identities of all. In other words, in the next month while we do identities, you're going to use this guy in some form or another over 100 times. So please memorize it. I will remind you that not only does this identity come this way, but you can move the sine squared theta over to the right, and that means that the cosine squared theta is equal to 1 minus sine squared of theta. Or you can also move the cosine squared theta to the right, which will then leave you with sine squared theta is equal to 1 minus cosine squared theta, and all three of those are the same identity. In my previous lesson, I taught you how to memorize these other two here, and that is by dividing by sine squared theta, sine squared theta, sine squared theta, and cosine squared theta, and cosine squared theta, and cosine squared theta, and you derive the other two. So these two come directly from that one. You saw that one on my previous lesson. And these are the Pythagorean identities that we will be sharing with you. Given that, let me give you a few hints. Let me start by telling you that there is no one way to do all the identities because they all vary. However, this is a unit where everything comes to play as far as all the math that you have learned. Because whether you are taking square roots, whether you're squaring a binomial, whether you're simplifying, finding common denominators, conjugates, you name it, it all comes to play here. Except that in the previous classes, it was always x's, y's, and z's, and now there's sine thetas, cosine thetas, and tangent theta. Now, I keep saying theta. Remember that theta is just a variable. It could be any other variable, like U or any other letter in the alphabet, okay? So let me give you a few hints here how to solve them. Now, I already told you that not all roads necessarily lead to Rome in this case. In other words, there's not one way for you to get to Rome. There's many roads to get there. So let's try some hints here. So when you're stuck, remember that this is probably a good way for you to do this, is to always try to change everything to sines and cosines. And if you do that, something magical will happen along the way. Things will cancel out, and voila, things will simplify. Sometimes, however, you're going to end up with a fraction. For example, you're going to end up with 1 over sine. And that's a fraction. We don't want to end up with 1 over sine, in which case you're going to do this reciprocal identity, and you're going to change that to cosecant of theta. So sines and cosines all the time, and if you have fractions, get them out of fraction mode. Later on, as they get more complicated, you're going to see that sometimes you're going to end up with a denominator of 1 plus sine of theta, for example. And remember that the way to get rid of a binomial is to multiply by its conjugate. So if you multiply and rationalize by 1 minus sine theta on both top and bottom, you'll see that magic will appear yet again. Okay? Well, in this segment, we are going to be doing some examples. I did not get the opportunity to give you this packet before we left, before spring break. However, it is uploaded into the Google Classroom, and so you're going to have to download one page at a time and work on these. You can do them on the paper here because these ones are not that long. However, I do recommend that you do them on a separate sheet of paper because the left-hand side of either they may be really easy, the right-hand side ones may not be. So in this segment, I'm going to cover 1 through 11, and then you're going to check to see if what you did at home matches what I did here. I may have done them in a different way. Just remember that there is no one way to do all of these, but I'm going to try one way, and if you like this way, do it this way, and if you like your way, so long as you end up with the same answer and all the mathematics is soundproof, then no problem. Go ahead and submit it. So let's go ahead and begin here. Because this paper is kind of small, I'm going to push that over to the side, and we're going to do the examples right here because they're a little bit bigger. Let's begin with number 1. And like I said, all the ones on the left-hand side are very easy. Let's begin with this one. The left one here is already a sine of theta, so you're just going to rewrite it. Sine of theta. You're going to use the reciprocal identity, and I know that cosecant is 1 over the sine of theta, and therefore, you're going to show me all of these cancellations. I really want to see the cancellations. You're going to cancel top to bottom, numerator to denominator, and the answer is 1. Yes, it's really simple at the beginning. Let's move on to number 2 here. You're going to notice now that I have a cotangent and I have a sine. So I'm going to change the cotangent. What am I going to use? Well, I'm going to use the quotient. I know that cotangent is cosine of theta over the sine of theta. I'm going to leave the sine of theta because it's already a sine. And when I cancel, something cancels. Yes, they do. Show me the cancellation, and you are left with the cosine of theta. And that's number 2. Okay, let's move on to number 3 here. Again, I'm going to use the quotient, and I'm going to change tangent of theta to what? Yes, indeed, sine of theta over the cosine of theta. I'm going to change the cosecant by using the reciprocal to 1 over the sine of theta. What cancels? Well, the sine of theta with the sine of theta. What do I have left? 1 over cosine. So 1 over cosine of theta. And finally, I said no fractions, remember? So go back and change this. What is 1 over cosine? Well, it's going to be the secant of theta. You're going to notice that I work downward. I need for you to understand that I want you to work downward and not to the right. There's no equal signs yet. They will be later on. Right now you work downward, and that's why you need plenty of space. So please use a separate sheet of paper. Number 4. Oh my goodness, I think I recognize this. Yep, it's right here. 1 plus cotangent squared of theta. What does it equal to? Cosecant squared of theta. So all you got to do is just in one step tell me that this is cosecant squared of theta, and you are finished. One good way for you to remember, by the way, is that tangent goes with secant and cotangent goes with cosecant. So C goes with C, if you want to remember it that way. That takes care of number 4. Moving right along, like I said, all the left-hand side on your worksheet here are very easy. Again, I'm going to change this, and I'm going to notice that if I use a Pythagorean one, if I move the sine squared of theta this way, I will end up with cosine squared of theta. But if I move the cosine squared of theta this way, I will end up with sine squared of theta. So what is 1 minus cosine squared of theta? And the answer is simply sine squared of theta. And you are finished. Okay, number 6. Let us use the quotient. What does tangent squared of theta equal? Well, it equals to sine squared of theta over the cosine squared of theta. And then you just bring down the cosine squared of theta. As I told you before, something usually cancels. Yes, indeed. Let me go cancel the cosine squared of theta. And what am I left with? Sine squared of theta. Wonderful. That takes care of number 6. Number 7. Well, let's see. Now I've got 3 of these. Which one can I change? Well, I'm going to leave the cosine theta alone. So cosine theta stays. But I'm going to change cosecant into 1 over the sine of theta. And I'm going to change the tangent into sine of theta over the cosine of theta. Okay, cancel the sines, cancel the cosines, and of course, when everything cancels, the answer is simply 1. Number 8. Hey, I have a little friend here who wants to learn identities. Why don't you just leave me alone for now, and tomorrow I will show you, okay? Bye! So now let's move on here. Sine squared of theta, 1 minus cosine squared of theta. Hey, I recognize 1 minus cosine squared of theta. That's the Pythagorean identity. If I once again move the cosine over to the right, I will end up with sine squared of theta. So my numerator is sine squared of theta. My denominator turns into sine squared of theta. And what is sine squared of theta divided by sine squared of theta? Whoopsie, it's 1 again. And that takes care of number 8. Okay. 3 more and then we're done with the left-hand side, the easy ones. Okay, what is 1 plus tangent squared theta? Oh, well, I remember that Pythagorean. 1 plus tangent squared theta is equal to secant squared theta. So let me change it yet again. This is secant squared theta. This on the bottom stays as secant squared of theta. And what is secant squared theta divided by secant squared theta? It is 1. Number 10. Oh my goodness. This takes us back a long way, all the way to algebra 1. I have a parentheses. And what are you supposed to do when you have parentheses? What's the name of the property? Yes, that's right. It's called a distributive property. And this is the way your teacher probably showed you to use the little arrows, right? So the first thing you always do in PEMDAS, please excuse my dear Aunt Sally, the order of operations, is for you to always get rid of the parentheses, right? So let me go ahead and do that. This gives me sine of theta cosecant theta minus sine squared of theta. There are no more parentheses. I can now move on. So now let me fix some of these. Sine theta stays as that, but 1 over cosecant theta changes into 1 over sine of theta minus the sine squared of theta. Again, these cancel out. You're left with 1 minus sine squared of theta. And of course, I'm getting good at this. This is the Pythagorean identity, which changes into cosine squared of theta. Last one on the left-hand side, okay? Let's see. This one has its own page. Maybe it's a little bit harder. Let's go check. What does 1 plus tangent squared theta equal? Well, once again, 1 plus tangent squared theta is equal to secant squared theta. So let me change that to secant squared theta over the tangent squared of theta. But as you already know, we cannot have fractions. We cannot have secants and tangents. So I'm going to change these to however I can to sines and cosines. The numerator changes to 1 over cosine squared theta. The denominator changes into sine squared of theta over the cosine squared of theta. Now, what happens when you have a fraction divided by a fraction? Well, the denominator flips over. You get the reciprocal, and it changes into multiplication. But as you already know and have seen when we did rational expressions, the denominators just simply cancel out, and you're left with 1 over the sine squared of theta, which of course, no fractions, we know it as cosecant squared of theta, and that is questions 1 through 11, okay? Well, okay, let's begin now with number 12. You're going to notice that they get a little bit more challenging, okay? Let's begin with the first one. I'm going to change the cosecant into 1 over the sine of theta, and I'm going to leave the bottom one, sine of theta, over 1. Minus, I'm going to change the cotangent into cosine theta over the sine of theta, and the denominator, I'm going to change the tangent into the sine of theta over the cosine of theta. So what you see here is 4 fractions. I'm going to take the reciprocal of this guy and get a new fraction. And I'm going to take the reciprocal of this guy, get a new fraction, and I'm going to go from 4 fractions into only 2. If I do this one here, I will end up with 1 over sine squared theta. Minus, if I flip this guy over, you'll end up with cosine squared theta over sine squared theta. It's beginning to look a little bit nicer. So now I'm going to notice that I have 2 fractions and I need a common denominator because I am subtracting. But wait, I already have a common denominator of sine squared of theta. So just rewrite 1 minus cosine squared of theta. But I recognize that 1 minus cosine squared of theta is sine squared of theta. I'm going to leave the denominator of sine squared of theta. And what is sine squared theta divided by sine squared theta? It is 1. Beautiful. Okay, there you are, number 12. Nice and long, beautiful. Let's move on to number 13 here. I see 3 expressions. Oh my goodness gracious. But wait, I'm going to recognize this one here. That's the Pythagorean identity, which changes into 1 plus tangent square theta. Hey, that's the other Pythagorean identity. 1 plus tangent square theta changes into secant square theta. Okay. Number 14. Now I have 4. Okay, 4 expressions. So let me change everything to sines and cosines and see what happens. I'm going to begin by changing the cosecant of theta. So leave sine of theta alone. Change this to 1 over the sine of theta plus sine theta over cosine theta times cosine theta over the sine of theta. All right. Now let's go cancel and see what we get. The sines cancel. The sines over here cancel. The cosines cancel. You're left with 1 plus 1, which is 2. Not too shabby. Pretty cool. That's number 14. Okay. Let's move on to number 15 here. Number 15, I am going to notice that there is a secant there. So once again, I'm going to change the secant. I'm going to change this to the cosine of theta, leave it alone, 1 over the cosine of theta. Minus the cosine of theta, change that secant to 1 over the cosine of theta. Okay, red marker here, cancel the cosines. 1 minus, do the reciprocal here, cosine square theta. And what is 1 minus cosine square theta? Yes, indeed, it is the sine squared of theta. Okay. Number 14. Oh, that was 15, so it must be number 16 that's next. Okay. Oh, wait a second. I recognize 1 minus sine squared theta. That turns into cosine squared theta. And I also recognize 1 minus cosine squared theta. That turns into sine squared theta. And no fractions. What is cosine squared theta divided by sine squared theta? It is cotangent square theta. Let's do it again. This one is very similar to that one. What is 1 minus cosine squared theta? It is sine squared theta. And what is 1 minus sine squared theta? It is cosine squared theta. So when I divide this, sine squared theta divided by cosine squared theta, of course, is tangent squared theta. And that is all the way to number 17. Okay, moving right along to number 18. I have 2 square roots. And some of you may think, well, they're all squared, so let me get them out of the square roots. But of course, that's not possible because of the minus. In other words, this -1 is married to the secant square theta, so they can't get out of the little house's square root, right? So therefore, let me use my identities and change both of these. You see, secant square theta minus 1 turns into tangent square theta. And what does cosecant square theta minus 1 turn into? It turns into cotangent square theta. So now there's no longer any marriage. The square and the square root cancel, the square and the square root cancel, and you are left with the tangent of theta all over the cotangent of theta. Now I'm going to change the denominator because we don't like fractions. I'm going to leave the tangent of theta alone. So tangent of theta divided by 1 over the tangent of theta. And when you take the reciprocal, you will end up with tangent squared of theta. Now you're probably wondering, why don't you change it to sine and cosine? Because if you did that, oops, no square. Oh yeah, because you brought it up, yes. I was saying that you don't change it to sine and cosine because if you did that, you would end up with sine squared theta over cosine squared theta, which is a fraction, and we don't want fractions, right? Right on. Number 19. I now see 4 items. Oh my goodness, and there are pluses in between. So now I got to change everything to fractions. Let's see. I'm going to leave the sine of theta alone. I'm just going to put a little 1 on it. Sine of theta over 1 plus the sine of theta over the cosine of theta all over 1 plus 1 over the cosine of theta. 4 fractions. Well, when we did rational expressions, we learned that if we have 4 people going to the movie theater, you look at the denominators, and what's the name of the ticket? The lowest common denominator is cosine of theta. Right on. So let me go give them all what they need. Since cosine of theta is the lowest common denominator, what does this guy need? It needs a cosine of theta. Cancel your denominator. This guy already has a cosine of theta, so cancel your denominator. This guy needs a cosine of theta. Give it to him and cancel your denominator. This guy already has it, so just cancel your denominator. If you did the math, here's what you now have. Sine theta, cosine theta, plus the sine of theta is my numerator. And in the denominator, cosine of theta plus 1. Now we're going to take a look at the numerator and see if we can factor something out. And yes, there is a greatest common factor. It is called the sine of theta. When you factor it out, you end up with cosine of theta plus 1. And the denominator stays as cosine of theta plus 1. Okay? These two expressions cancel out. If you want to see the parentheses, there are. And all you got left is sine of theta is your answer. Wow, we're almost done. So number 20 is probably the hardest one. So I'm going to write a little bit smaller because it might be a little bit long. Let's begin by changing the tangent theta to sine of theta over the cosine of theta, plus changing the cotangent to cosine of theta over the sine of theta. And in the denominator, I'm going to change the cosecant squared of theta to 1 over sine squared of theta. Now you're going to notice that there are 3 fractions, which means I got to go find a common denominator between all 3 of them. In other words, what's the ticket? The lowest common denominator is cosine of theta, but sine squared of theta. So now we ask, what might they be missing? Well, let's see. This first one here has the cosine of theta, so it's missing sine squared of theta. This second one has a sine of theta, so it's missing a cosine theta and a sine of theta. This last one here down below has a sine squared of theta, so it's just missing the cosine of theta. So when I cancel all of my denominators, what do I have left? Well, let's see. It looks like I have sine cubed of theta plus cosine squared theta sine of theta all over the cosine of theta. So now take a look at the numerator and see what they have in common. That way I can factor out a greatest common factor, which is the sine of theta. If I do that, I will end up with sine squared theta plus cosine squared theta all over the cosine of theta. You should at this point recognize that sine squared theta plus cosine squared theta is 1. So sine of theta times 1 over cosine of theta. And finally, cosine of theta being below sine of theta is the tangent of theta. And that is number 20. In number 21, I'm going to change the tangent squared of theta based upon this identity here. I'm just going to move the 1 over to the right-hand side. So tangent squared of theta will equal to secant squared of theta minus 1. Secant squared theta minus 1 all over the secant of theta plus 1. And then, of course, the plus 1 over here. Now, this is called the difference of 2 squares. So I'm going to change that into the difference of 2 squares. Secant of theta plus 1 is my denominator, and then my 1. The difference of 2 squares is secant theta plus 1 and secant theta minus 1. You should notice that these two things cancel out, leaving you with secant theta minus 1 plus 1. Well, wait, the plus 1 and the minus 1 cancels out, so your final answer is the secant of theta. And finally, number 22. This one is a beauty. You will remember that this is squaring a binomial. And the 4 steps to squaring a binomial are square the first, square the last, multiply the 2, and double. I'm going to do it twice. Here we go. Sine square theta, square the first, plus cosine squared of theta, square the last. Multiply those two and double. So that's plus 2 sine theta, cosine theta. That's the first one. The second one, there's a plus there. So square the first, square the last. Multiply those two and double is minus 2 sine theta cosine theta. And of course that's a plus because I'm squaring. Now what cancels? Well, the whole middle terms cancel out, leaving you 2 sine theta plus 2 cosine theta. But of course they're both squared. What can you factor out? A 2. Sine square theta plus cosine square theta. When you factor out the greatest common factor, that'll leave you 2 times 1, which is of course 2. And that's the end of my identities lesson. So now you are supposed to go and check to make sure that all 22 of these were correct when you did them. And then of course for you to finish up letter B, letter C, and letter D for this week. Next week, we will worry about E, F, and G, and H. And then we will keep going all the way to letter M and N and so forth and so on. For now, this is Mr. Gonzalez saying good night, have a good day, and remember, if I can teach from anywhere, you can learn from anywhere. See you soon. Bye-bye.